Okay guys, so I'm just going to be walking through an example of a system of differential equations and how to find a full solution and how to graph it. So let's go. This is the question. Pretty standard question. So from this, remember the characteristic equation is r squared minus the trace, so minus -7, plus the determinant, which is minus 5 times minus 2, 10 minus 4, so it's 6. Factoring this is pretty easy. Therefore, pretty straightforward, finding the eigenvalues of this guy. Now, to find the eigenvectors, we're going to take these eigenvalues, subtract them from the diagonal. So subtracting -1 is equal to adding 1. So add 1 to the diagonals and then leave the other entries the same. Like so. And then filling this guy in is pretty straightforward. 1, 4. There we go. So for eigenvalue 1, or the first eigenvalue or vector, is 1, 4. And that was for r equals -1. For r equals -2, or -6, what we're going to do is we're going to add 6 to the diagonal entries. 1, 4, and then leave the other entries the same. Solution to this is pretty obvious. You need one minus the other, so there. So for r2 equals -6, our second eigenvalue, or eigenvector, is 1, -1. So next what we're going to do is we're going to, oh right, there's an initial condition too, my bad. That. So next what we're going to do is we're going to use these two eigenvectors with these eigenvalues to write out the solution to this guy. There. Now I have to solve for C1 and C2 using the initial condition. So plugging in t equals 0 everywhere, we get in other words, we know that the first entry of the C1 times the first entry here, C2 times this first entry here has to equal the first entry here. So C1 plus C2 equals 2, which means, hold on, I'll leave that for later, and 4C1 minus C2 equals 1. So we want to isolate for C2 here, so we can say C2, 2 minus C1, which by plugging into this equation, it's going to give us 4C1 minus 2 minus C1 equals 1. Multiplying the negative out and adding them together, 5C1 minus 2 equals 1. Therefore, C1 equals 3/5. basic algebra. And from there, since the first equation is so simple, you can jump straight to there. Pretty straightforward. So, okay, so our solution, our specific solution, oh, right, we know C2. Whoops. Is that. Now, we're faced with the task of having to draw this. So how are we going to do that? So first, let's start with our axes. Probably shouldn't move it down so much. Like that. And like, man, hold on. It seems disproportional. It's just gonna get on my nerves. Okay, good enough. So we have our axis system. This is x1, this is x2. So the first step in doing this is think about back to the general solution, what we had up here, right? If C2 is 0, then this term is gone, and we're only left with this term. Now, this term has a constant being multiplied by e to the negative t, which just changes in value, but the direction doesn't change. Because remember, a vector also has direction, but scalar values don't. So what this is doing is it's just going to multiply any vector that we have along this direction, 1, 4. So what we need to do is we need to draw that that vector, the line that corresponds to the direction 1, 4. So go 1 over, 4 up, and like that. So that's the direction 1, 4. Now, going back to the general solution, doing the same thing, assuming C1 is 0, what we're left with is this term, which is in the direction 1, negative 1, and this guy is only scaling the vector and changing its direction, but it's still along this direction, like 1, negative 1. So we're going to go back to our diagram. We're going to move 1 over, go down 1. There we go. And we're going to draw a line through that in the origin. Like that. So that's a direction 1, negative 1. But that's assuming that C1 and C2 are 0. Now what we need to do is we need to fill in, first of all, right, we need to have direction arrows in this. Let's think about the situation in which C2 is 0. This is gone, right? As t progresses, this number, e to the negative t, gets smaller and smaller and smaller, which means the length of the vector gets smaller and smaller and smaller. So as t increases, the length of the vector that we're talking about gets closer and closer to 0, which means here, along this line, as t progresses, we get more and more to 0. Now, from negative t, we have the same, or it's the same idea. As t progresses from either direction, we're going to be getting closer to the origin. Like so. And the same argument goes if c1 is 0, since this is a negative exponential, as t goes to infinity, this guy goes to 0. So once again, even with the other line, we have that it approaches 0 as t approaches infinity. There. So we're starting to draw the direction field of this guy. Next, what we're going to be doing is we're going to be thinking what happens when we have both of them. Because when we have C1 and C2, we're somewhere in these regions that aren't on the line directly. So when t is very, very, very negative, so at the very starting, when t is incredibly negative, this guy is dominated by e to the negative 6t. Because as t is negative, this is going to be e to the 6 times the absolute value of t, which is bigger than e to the t, because of the factor of 6. So this term is going to be dominating it, dominating at high values of, or very, very negative values of t, which means it's going to start off parallel to this vector. And then on the flip side, as t gets very, very, very positive, what's going to be happening is this guy is going to start dominating, because as it's positive, then these both go down to the denominator, in which case these get closer to 0, but this guy gets closer to 0 slower than this guy. So this vector is the one that dominates as t progresses. So what that looks like on this diagram is you start off parallel to 1, negative 1, and now I'm going to turn this sideways actually. And as you get closer and closer, it turns to become parallel with 1, 4 and approaches the origin. So, like that. And that's as t progresses. So, if we keep drawing these out, and it's just going to keep doing the same thing. Like that. And then you just keep drawing them for the rest. Sorry. And then we have there you go. And just going to keep going. Sorry, I gotta like turn my paper to be able to draw this easier. There. So that's what the slope field of this guy looks like. And then when it asks draw the specific solution, we just start at the point 2, 1. So 2, 1, let's say about here. Yeah, that's about right. And all you have to do is follow the direction lines. There. And the green is the solution. And that's it. So, cheers.